In this video, I'm going to show you how to use the law of cosines to find the measure of an unknown angle within a triangle. So here we've got a triangle labeled with angles A, B, C, capital letters, and then the sides are labeled with lowercase letters across from the angles. So across from capital angle A is lowercase side A, and then across from capital angle B is lowercase side B, and then across from capital angle C is lowercase side C. And for this triangle, we have a relationship between the sides and one of the angles, and it's called the law of cosines. And it goes like this: c squared, the side c squared, is equal to a squared plus b squared, those sides, minus 2 times a times b, times cosine of angle C. And you might notice that if you cover up the minus 2ab cos c part, you just get c squared equals a squared plus b squared, which is just the Pythagorean theorem. So the law of cosines is kind of like an extension of the Pythagorean theorem. Whereas the Pythagorean theorem only works on right triangles, the law of cosines works for every single triangle. In fact, in the case of a right triangle with hypotenuse C, in that case, the angle C would be a right angle, 90 degrees, and cos of 90 degrees is just 0. So this whole term would just go to 2ab times 0, which is 0, and that would reduce to the Pythagorean formula. So the Pythagorean formula is really just a special case of the law of cosines. The law of cosines is more general to every triangle. Now, we also have some alternate forms of the law of cosines, which come just from swapping some letters within the naming convention of the triangle. So in the alternate forms, we also have a squared equals b squared plus c squared minus 2bc cos a, and b squared equals a squared plus c squared minus 2ac cos b. Now, there's a pattern that goes throughout the original statement of the law of cosines and also the alternate forms. In general, the law of cosines just says that you can start out with a side length squared, and that's equal to the sum of squares of the other side lengths minus 2 times the other side lengths times cosine of that angle that corresponds to the side that you started with. And that's the way it is for all of the alternate forms as well. Here's an example of the law of cosines in action. So we want to use the law of cosines to find the value of measure of angle C in this triangle here. And we know the side lengths of the triangles. We know that 5, that's just equal to side small a, because that's across from angle A. 3, that's equal to side small b, because that's across from angle big B. And then 7 is equal to side C, small c, across from angle big C. And in order to find what measure of angle C is, we should set up a law of cosines which involves cosine of C in it. So we can just plug in the side information. C, small c is 7, so 7 squared is equal to a squared, and a is just 5, so 7 squared equals 5 squared plus b squared. Well, b is just 3, so 3 squared, and then minus 2ab, so minus 2 times a is just 5, and then times b is just 3, and then times cosine of angle C. Times cosine of C. And we don't know what big angle C is, but now we have an equation where that is the only variable, and we can solve that equation. So why don't we go ahead and solve this? So first of all, we'll just simplify everything. 7 squared is 49. So 49 equals 5 squared, 25, plus 3 squared is 9. Then minus 2 times 5 is 10. Then times 3 is 30. So minus 30 cosine of C. Okay, let's keep on simplifying this. So 49 is equal to 25 plus 9, that's 34, minus 30 cosine of angle C. Now subtract 34 from both sides, you get that 15 is equal to negative 30 cosine of C. So divide both sides by negative 30. So negative 15 over 30 is equal to cosine C. We can simplify that a bit. Negative a half equals cosine C, and then you can just take inverse cosine. So C is equal to inverse of cosine of negative a half. And you can recall what that is. This happens to be a special angle, or you can punch it in your calculator. Either way, you'll get a result of 120 degrees. So there we go. That's what the measure of angle C is. That's 120 degrees. Here's another example. A triangle has sides A equals 10, B equals 5, and C equals 6. What is the measure of the angle between sides B and C? Okay, so this time we're not given the diagram of the triangle. We actually have to construct it ourselves. So why don't we start off with that? So let's draw our triangle here. Draw our triangle. We'll let it have, how about base can be A. A will be 10. Let's label that. A equals 10. And then how about the next side will be B. So let's make B over here, and that will be 5. Then the other side will be 6. So B should be a little bit shorter than the other side. So why don't we make it kind of like this? So there we go. That can be B, and then this other side can be C. All right, let's go ahead and label those. So B equals 5, and then C equals 6. Okay, so we want to use the law of cosines to figure out what is the measure of the angle between sides B and C. Why don't we also label the angles? This is C, then that one is B, and then this one is A, and the angle between sides B and C, well, here's sides B and C, so the angle between them is A. So that's what we want to find. We want to find the measure of angle A. So let's use law of cosines to find this. Now, we don't have the law of cosines written down either, so let's try to recall it. So we want to solve for angle A. So that means we need a cosine of angle A term here. So why don't we start off by writing that down? Cosine of angle A. Okay, and remember that whenever we have cosine of angle A, that the side corresponding to that angle appears on the other side of the equation. So let's put an equal sign around over here and let's write side A squared over here. Okay, and now remember that the law of cosines is kind of like the Pythagorean formula in that it goes one side squared equals the sum of the other two sides squared. So A squared equals B squared, then plus C squared. And then we have a minus term there. So that's extra in the law of cosines, minus 2 times those two sides, times B times C times cosine of angle A. Okay, there we go. We've got it written down, and now let's just go ahead and fill in information. So A squared, A is 10, so 10 squared is equal to B squared. B is just 5, so 5 squared, then plus C, so plus 6 squared, minus 2BC, so minus 2 times 5 times 6 times cosine of A, big A, angle A. And great, so now angle A, big A, is the only variable in our equation here, and we can just go ahead and solve for it. So let's simplify. 10 squared is 100. 100 equals 5 squared, 25, plus 6 squared, 36, minus 2 times 5 is 10, times 6 is 60, cosine of A. Simplify even more. 100 equals 25 plus 36, that's equal to 61, minus 60 cos A. Then subtract 61 from both sides. On this side, you'll end up with 39. So 39 equals negative 60 cos of A. Then divide by negative 60. So negative 39 over 60 equals cosine of A. You could reduce that fraction, but let's not bother with it because we can just say that A equals inverse cosine of negative 39 over 60 and just stick that in our calculator and see what comes out. The result is that that's approximately equal to 130.54 degrees. So there we go. There is our measure of the angle between sides B and C, angle A, just 130.54 for degrees. Great, so now we know how to solve for missing parts of triangle using the law of cosines, and in the future we'll also see how to apply this knowledge to word problems.